All right. Well, thanks for joining today to take a nice look at the passwords and what we can do with more advanced approaches to password cracking. Once upon a time, when I was much earlier on in my exposure to the offensive arts, as I'll say it, I took a liking to password cracking just because it was an easier thing to kind of get started with in terms of doing offensive work. I think a lot of people kind of find an interest in that early on when they're getting into pen testing and offensive work. But it was also something I could do separately. I could download dumps. I could take a look at different things. I could generate my own hashes and then see if I could find good patterns for how to crack those, etc. And it was an interesting challenge because it was a great combination of hacking both the technology and the people. It's figuring out how your processor and your GPUs and all that stuff works, and how you can optimize that entire process and get the most out of it. And there are a lot of examples out there, dumps that you could use and go through and crack. And eventually I downloaded the LinkedIn password dump and was able to go through and start cracking on those. And but before that, I had an old backtrack install running on a very old computer underneath my desk. It was all that I could get at the job that I had. There's no GPU in it. It was it was probably a 5-year-old desktop when I got a hold of it, and at that point, very old. But it was something that I could keep up and running and install whatever I wanted on it. So I was installed that, ran quite a bit, and played around with all sorts of different stuff. And early on, I thought that the thing to focus on was getting as many password lists as I could, because I thought, well, surely you just get enough password lists, and you'll find the biggest number of passwords from various folks in the various dumps. So there's real common ones that were around, like rockyou.txt, phpbb, and myspace.txt. And some of those you can get out at Skull Security. I've got the links here up on the site. And I also then discovered the CoreLogic's Crack Me If You Can contest. And so if you go out, they've got all the previous contests listed out on their site. We've got a link to a list of all this contests later on. But in there, they had a word list page. So I went to the word list page. I had all sorts of different stuff. I had Facebook names, had another copy of RockYou, RockYou sorted by the number of uses, the types of password length, all sorts of stuff. And it went a lot deeper than what I thought I needed to have. But I just kept collecting the password lists. So as I went along, right, I kept doing the password cracking wherever I could in the engagements we were doing in my company, but didn't often get to use it as much as I wanted. But I had this giant list of, this giant folder of password lists and stuff that I'd been playing with and practicing, but I hadn't been able to put it to complete use at my company yet. And then it happened. So I was working at a Fortune 500. I'm sitting at my desk, and up behind me walks a CISO and a VP, right? So they come up to my cubicle, and they've recently been around the layoffs, and they'd let the person go that was managing all the data for upcoming pay raises and bonuses. All that information was put into a spreadsheet, and they'd put a password on the spreadsheet. And so while I had been very focused on passwords like NT passwords and landman passwords, and looking at SHA-1 hashes, MD5, that kind of stuff that are in common when part of a dump, I suddenly had to figure out how to crack a password on an Office document. Well, there's a lot of tools out there you can buy, like Elcomsoft has stuff that you can get, and a few others. But I've done all this work with John the Ripper and some other tools to figure it out. And it was, all of a sudden critical that I was able to get this done, right? Because we've got a whole bunch of people that are depending on their raise and bonus, and depend on me to get this password cracked so that the data can be processed in time for all that to be submitted and everybody to get it on the scheduled paycheck, right? Yeah, no pressure, right? So, they're standing behind me, and it's like, yeah, I'm gonna need you to go ahead and crack this password, right? And there's part of me inside of me that was just yeah, I've been prepping for this for a while, right? And I was excited. I really was, because I thought, okay, all this stuff I've been studying, I haven't been able to use it quite as much as I wanted. But now all of a sudden, that opportunity's come to me, and I've got that chance to do something that's actually going to make a difference for the company. A lot of times we do work in security, and nobody can necessarily see the benefits of our labor. And this was one of those times that I thought that security was going to get to shine a little bit, right? So, right, start cracking away on these passwords. Had close to 2 weeks to get it done, right? Based on when the date was they needed these passwords back. So, okay, I've got an Excel sheet. It was done by somebody. It's not in IT, right? The chances that they use a complex password to encrypt this thing, I figured not a high likelihood that they'd put a real complex password on here. I'm thinking this is going to be easy, no problem. The first thing I did was go out, and there's a Python script that comes with Jon the Ripper called Office to Jon. You just point that at the file that you got, and you can dump out the results into a nice little hash file, and then kick off Jon the Ripper, right? Well, with the assumption that this is a rather not complex password, I kick off a nice little one-liner for loops. I say for WN ls word list, so it's going to list out every word list in my word list directory, and it's going to kick off and run Jon the Ripper against the hash with the given word list, right? And then start over. So that should go through pretty quick. I had quite a few word lists in there, but it wasn't something that was going to take forever, right? But later that day, I came back, it was done, and there's a lot of output to go through. So instead of like trying to read through all the junk that Jon spits out, I just did a Jon -- show to take a look at the hash file and say, okay, where do I stand? And it pops out and says 0 password hash is cracked. And like at that point, my heart sank a little bit, because like, oh, well, crap, because I thought this was going to be easy, right? I'm like, oh, well, that's silly. I totally forgot to add the -- rules at the end, telling Jon the Ripper to add all of its special rules and use cases. So I kick it off again, and that takes a little bit more time, right? It goes through all that stuff. It goes through it does all the different permutations, changes case, swaps out characters, least speak substitution, all the way through all those different lists again, and nothing, right? And we're talking days later at this point. So like I've at this point burned almost an entire week. Now, granted, I don't have great hardware to work with. It's a really old, crappy computer. But all of a sudden, right, time's running out. So commandeered some other machines, other stuff, kicked off some brute force cracks with Jon the Ripper that I could just let run, and let them run constantly, while I worked on trying to optimize my word lists and figuring out there are different rules I could create and figure out what to do from there, right? Well, that's where like I all of a sudden had to go back to the drawing board completely. It's like, well, I've got all these word lists. I've got a whole bunch of different configs I thought were going to be better. I've had looped through all those word lists. Now what, right? Well, I'll come back to that in a little bit. Where I went from there was much deeper into all the different things I needed to know to be better at password cracking, do it effectively when time's of the essence and when it actually matters. Prior to that, I grew up on the Windows side of the house, so learning all the ins and outs of Unix and Linux, I didn't really get into that until I got into security about a decade ago. And so I had kind of avoided certain aspects of the command line on the Unix side because it was just a lot different than Windows. I couldn't point and click with it, and I had a lot to learn there. So I picked up some of that as I went along, because I all of a sudden had to start learning to pick up all the different ways you can manipulate text files inside Unix and Linux. Once I learned some of these basic things, and I've got a lot of them listed here, things like cat, cut, and cat's pretty easy. But the cut, grep, sed, awk, head and tail, vi, Unix to DOS, DOS Unix, all those things. And then also like, taking the time to learn regex a little bit better. I knew some, but not a lot, right? As you get deeper into all those, it gets a lot easier to kind of manipulate all the different text files and extract the types of hashes that you need. In fact, like I've got a link here out at Unix Ninja's site, and he's got a fantastic list of cheat sheet one-liners for password cracking. And it's not just items like, here's some command line options to run Jon. He's got a bunch of different things that are like extracting hashes from different types of files and that kind of thing. So just a couple of examples there. So we'll run through using grep and then a bunch of regex stuff. Now those are all things that you can figure it out once, and it's definitely the type of stuff you want to put into a cheat sheet. But this list is absolutely invaluable if you get into the password cracking stuff, and having it handy and the ability to use that quickly. So it's going to make it a lot faster and easier for you to use it. Now, the important thing though is that you also learn what all that regex stuff is. So if you go back a slide, one of the best ways I've found for folks to learn regex is the regex1 tool, right? So out here at regex1.com. It's a great site that will go through, and it teaches regex step by step, which doesn't seem like you would need to know that as you get into password cracking, but it ends up really important and really helpful as you go through and start using those Unix command line tools for editing, manipulating text, and all that. Right. So all that stuff's used to manipulate, manipulate text files, extract text from, or extract hashes from files as necessary. But there's also some tools out there that will go a long way in terms of helping you develop some better password lists, right? So we talked about some of these in various classes with SANS, but there's a few others that we haven't talked about as much. First one is Cool. If you're not familiar with Cool, it will go out and crawl a website and take words from the website and put them into a custom list. And you can do that for the corporation, the company, and that's going to help create that customized list. And it's good, right? It does a lot of great stuff in terms of targeting a specific organization. But the creators of Wordsmith kind of went a step further. Right? And Cool's awesome for going after and creating a very targeted list for an organization, but it's not always going to get the stuff that matters for maybe a geographic area, right? So Wordsmith focuses in on the geographic side of that so that you can create custom word lists for all the different like sports teams, college teams, and that kind of stuff, special attractions, landmarks, and that kind of stuff in a geographic area that are more likely to be part of the a password that somebody might use. So words that you might not have in your normal dictionary, but once you start applying the rules that Jon the Ripper and Hashcat give you, it gives you a lot more option in terms of what you can do and what it's going to pull back and what it'll generate. I'll get a little bit more into that in a few minutes, but some other ones are real helpful. So Derby is actually a tool that is focused on brute forcing web applications, right? So looking for directories and content and that kind of stuff. But it has a gendict tool, which is a very simple tool to use. You basically just type, if you're on Kali, it's installed on Kali, but you have to do derby-gendict, and then you can create a word list or create a base word, and then with a capital X, you can then specify what you want to replace any capital X with in that base word. So you can do numbers, letters, alphanumeric stuff, whatever, and create very customized lists for very quickly from the command line. It's pretty cool. And then HTML to dict is an option to, you get the HTML for a page, you point the HTML to dict at the saved HTML file, and it basically does the same thing that Cool does, but it's just one more tool that'll go through and do it. So I always like having multiple tools to help me get through these things, because there's always a time when those tools either don't work or you just run into issues with it, right? And then there's Crunch. Crunch is awesome. Crunch will take a word or a length and just kind of brute forces every combination of it and spits it out to a file. Can produce some very, very large files, which is can be helpful or it can be a hindrance depending on how big that file ends up getting. But it's very useful having, definitely something to keep an eye on and have in your arsenal. And then last year that I've got listed is Pack, and it's not necessarily for better passwords, but it's it's a fantastic tool for going through and generating statistics about the passwords after you've done the cracking, right? And that will help you identify patterns, opportunities for training for the organization or your organization, and produce a nice report that you can include either in your pen test or for your management to see where they can improve. All right. Additional tools that come with Jon the Ripper, and this is only a portion of what's available. I just called it anything to Jon. It's really an insane number of password formats that they have scripts for, written in combination of Perl, there's Python, there's a few I think that are actually binary files. And basically what it is you compromise something. So, well, in my case, I had the Excel spreadsheet, right? So I would use the Office to Jon option, and then from there, it would produce the hash from that file and kind of dump it out. And that's what all these different tools do. So very helpful in terms of, you stumble across various file types. And there's stuff on here that I really don't even know what it is, but Jon the Ripper has the ability to, or these tools in Jon the Ripper have the ability to go in, pull a hash out, and then use Jon to either start cracking on it, or if the hash is supported by Hashcat, you can use that as well. A couple features in Jon that I've always really enjoyed. Once they've added them, really, really helpful. The first is the Jon --config option. So with the --config, what you can actually do is specify a custom jon.conf. And with inside jon.conf, you can really configure just about all sorts of different things about how Jon actually works. There's features in there where what you can actually do is disable all output of the actual password from the screen. So it won't save it to the screen, won't save it to the pot file, won't save it to the rec file or the log. And what you can do then is you have that, it'll give you then the idea of how many of these passwords crack, right? You can also then set that up with the ability to email and notify the users that their password cracked. All that stuff is configurable inside jon.conf. And when you set that stuff up that way, you'll be able to crack the passwords and potentially at that point notify your users so that they know that weak password didn't hit the complexity requirements that you're looking for, et cetera. But at the same time, it maintains some non-repudiation capabilities in there because you've not seen the actual password. You don't know what their password actually was, but you can still get the benefits of going through that patching process or cracking process. And inside jon.conf, you can also change like the default password list. Like I know folks that will, instead of using Jon's password.lst as the default password list, they'll change it to something like Rocky or some other password list that is their preference. So all sorts of options in there to go in and tweak and tune and make it work just the way you want. Also included inside the conf files are the rule sets that Jon the Ripper will use. So with the rule sets, you can dig in and go tell it to do various types of rules based on the type of password list that you're using, etc. So I mentioned before the core logic rule sets and the passwords that I downloaded from there. Some of those password lists were like, I didn't really understand what they were at first, right? If you dig into those, there were password lists in there that were just 2-character password lists. So everything possible with 2 characters, which I didn't really understand. But as you read through the rules, there were rules where it would have certain words or options configured in the rule, and then it would apply those specific 2, 3, or 4-character password lists to the end. And it would either prepend or append those words in that word list to the words specified in the rules. So it definitely changed how I went through and then started using the rules, because then I better understood when to use one type of rule with a certain type of password list. That changes quite a bit if you get into that. And one of the other big things I love about Jon the Ripper is the Loopback option. And this is something that I think a lot of people miss, but it's very helpful, very powerful, especially in situations where if you've got the landman password and it's cracked, but you're trying to crack the NT password, you just specify --loopback on the command line. And what that tells Jon to do is it goes back and starts looking at its .pop file, right, and starts using that as another source password list. So it'll go in, it'll see the LM password in this example, and begin cracking based on what that local landman password is. And with that landman password, it'll begin toggling the case, which is really what we're trying to figure out at that point, right? Because if we've got the LM password, everything is converted to uppercase, but it's not necessarily uppercase when the user entered it. And so it'll go through and quickly crack that stuff and move it back, or convert it back and crack to the NT password once you have it. So very helpful. A couple quick things about the performance options with Jon too. Jon has a bunch of different ways that it can optimize your CPU for cracking. So it has things like OpenMP, which is going to help it utilize multiple processes and processor cores on your machine. And it also has a --fork, which is in Unix only mode, but basically splits off separate processes to go through and do the processing. So you'll do a --fork equals, and then the number of processors that you have available for it to do the work. I'll do a demo of that in just a minute so you can kind of see the difference. And then you also have to use the right Jon, and that's not a bathroom joke, right? You've got to be able to have the right thing. So the default binaries that you go download from OpenWall, if you go get Jon the Ripper, are compiled for 32-bit use. And if you look at the performance, and I'll show you in a second, the difference between 32-bit and 64-bit is significant when run on a 64-bit machine. And so I'll go ahead and jump out of here real quick. All right. So this is Jon the Ripper on Windows, and this is a 4-core with 8 threads, i7 4790, 3.6 GHz processor. So a few years old, but still pretty fast. Tell it to do the test. All right, so it ran through, did the benchmark there, and then you can see it lists these combinations per second. And so this is in thousands, right? So it's basically 14 million combinations per second, right? Now, if I go to a virtual machine with Kali running on it, same machine, right? It's just a virtual machine. There's the speed difference here. So this is 58,077, or basically 58 million combinations per second. So that's quite a bit faster than what I was seeing over here on Windows. Now the only difference is the compilation of the binary. So this is a 32-bit binary, and it's just not efficient enough to keep up. Right? And then on Linux, we can do the --fork. And ideally what you want to do if you do the fork, you'll set that to be equal to the number of actual cores that you have. And then I'll do these. And top 10,000 is password list, passwords from Have I Been Pwned. I'll get to that in a few minutes, but they've released all the different passwords that they've had on Have I Been Pwned. So there's a lot. There's a lot of passwords in there. Now you can see the number on the left here is 1, 2, 3, and 4. So it's the process for each one that's running. Right. And so at this point, it's in brute force mode. We know that because it's 3,3 or 3/3. So it's phase 3 of 3 as it goes through there. But you'll see I've got 4 processes going at this point with 32,000 K each. Right. So I'm at 120,000 K, which is far more than what I was able to do with just the test by itself. And so I'm less than 60, right? And up here all together, it's going at around 120 plus. So quite a big difference there. And it's a matter of knowing that the fork option is there. Because if you just do Jon by default, I don't think it actually shows that in here. Yeah. Nope, there it is. Some versions don't show it. But the fork option is only on Linux. It does not actually work on Windows. Get my slides back up here. Yeah, so that's quite a bit about Jon the Ripper. Hashcat gets a little bit more interesting. So we take a look at Hashcat. Where Hashcat really excels is in the area of GPU cracking. And so it's a little bit more complicated to use. The command line options are a lot more confusing at first if you're not familiar with it. It takes a little bit of work getting used to it, and the vocabulary changes a little bit too. So it has basically 4 different ways that it goes through and does attacks. So the first is the dictionary attack, which is basically just trying all the words in a word list, and that's pretty straightforward. The combinator attack actually takes words from multiple word lists, and you can specify which ones those are, and then switch them on from the right side to the left side. So as you specify those on the command line, it'll take the words from the second list and start, injecting them at, at the beginning, at the end, in the middle, and all sorts of stuff in the passwords on the list on the left. And it goes through over and over and over and over again. And that can take quite a bit of time if that's how you go through and do it. It depends on the size of the list that you use. And mix and matching the different word lists there can make quite a big difference in terms of how well it performs for you. All right. And then the brute force mode, very similar to how Jon the Rip goes through it. They both will use Markov chains, and if you're not familiar with Markov chains, definitely something to do a little bit of research on. But the easiest way to describe that is statistically, what's the next likely character in the word? And so if it is the letter A and we're starting with A, statistically speaking, the likelihood of the second letter being A is low, but the likelihood of it being a consonant of some sort, like a D or a T, is much greater, right? So it will go through those statistical likelihoods, and it does it for not only individual letters, but it also does it for combinations of letters and words, so that it can take better guesses in terms of what those likely words are going to be. Because in reality, that people don't pick just random characters, right? They just, unless they're using something like 1Password or LastPass or something like that to generate it, and even then, they're not memorizing it, right? So a big piece of password cracking is we're not just attacking the technology, we're attacking people and how they operate and think and how they set their passwords. And then we have the hybrid attacks, when this is where we combine the word list and the mask together. And the mask you can specify with question marks, right? Question marks and then the type of character. So like a L for lowercase, a D for a digit, A for all alphanumeric characters, etc. And you can also create groups for those as well. I can demo that in just a minute. Now, the important thing with GPU cracking to keep in mind, and this is something I didn't really understand at first, but it's kind of critical to understand. GPUs are actually slower than CPUs. The individual cores are slower. The thing is that they have thousands of cores to make up for the fact that the individual cores are slower. And so where Hashcat and GPU-based password cracking really make up the difference is the parallelization. So it's having a whole bunch of things that are maybe a little bit slower, but doing 1,000 of them at once as opposed to a single operation. And so it makes up for that time very, very quickly. To fully utilize that GPU, though, we've got to be able to parallelize across all those cores. And to parallelize across all those cores, we've got to get enough data into the GPU for it to actually begin cracking and utilize all those cores at the same time. When you're actually running Hashcat, it'll tell you how effectively you're using all of its cores. So a big problem there is that the bandwidth to go from the main board and the processor to the GPU ends up a bottleneck. We can't pipe enough data through there to generate passwords on one side and have them crack on the GPU on the other. So what ends up happening is we'll send through, it breaks it into two different loops. There's a base loop and a mod loop. And so the words are sent to the GPU after the base loop. And the base loop will run on the host CPU and kind of send that through to the GPU. And then on the GPU, it has the second half of the rule processing, and that stuff runs on the GPU, where it generates additional candidates and applies rules to the passwords that have been sent across. And that helps keep all those cores operating while it goes through and runs those password hacks or cracks. So we can see from a demo of what this looks like here. Okay. So Hashcat, and the default download that you get is going to have some example scripts in there for you, so you can kind of see what those look like. And it'll have the binaries for both the 64-bit and the 32-bit. I'm using the 4.0.0 version at this point because the CPU version, the CPU specific cracking isn't working properly on 4.2 on my machine at this point. And I've not figured out exactly what that issue is, but I know 4.0.0 works. So we can take a look at, real quick, we'll just look at the example. So what we have here is we've got Hashcat. It's going to tell it the type of hash that it's going to run. It gives the hash file and then the dictionary that it's going to run. And so by default, it's going to run in dictionary mode. If we want it to run in a different mode, we have to specify that. Now, Hashcat has maybe like one of the longest help outputs of commands. So typically, if I'm doing Hashcat, what I like to do is send it out to less, because once I have it in less, I can actually search through it. I'm looking for a specific thing. So if I want to see, for example, NTLM, right? So then highlights exactly where all that stuff is for me. Okay. Let's say mode and then use N to go through and search. You can also then grep that stuff to look for exactly what, so we can find out what mode number we need to be able to provide. Right. So at the tail end here, it breaks down the different attack modes that we have, performance tuning, which is nice to have, cheat sheets for your built-in character sets and your masks. And then the modes, so straight mode, combination mode, brute force, etc. We can specify the format, etc. Now, with Hashcat, we can do the same thing to kind of benchmark and test the speed of the cracking capabilities, and we can do that with a couple options. So we can do it with a -b or the -- benchmark. And so if you do it with just the -b, it's going to go through and do it for every single hash that it can do now that has algorithms for. And that takes a little bit of time. So just to give the example here, we'll do it with the NT hash, since that's what I did for Jon. Goes through, comes back out. Now this MHS, people tend to confuse that with something like megahertz, and I sort of think of it that way, but it's not megahertz. It's hashes per second, and the M is broken into things like the mega and the kilo, etc. So that it's millions at that point, right? So when we're looking at 22,502 million hashes per second. Now, one thing I can do with Hashcat is also list out the devices that it has to crack, right? So what you saw before there, by default, it's going to use a GPU if it has it. And so I have an older GPU in here. It's a AMD, it's a RX 290, and so 290X. So it's okay, but it's again, it's a little bit older. It was great when I bought the computer. I think about 6 months after that, all the NVIDIA Titan stuff came out, and you know, I was a little sad, but it's served me well so far. So to compare the GPU to the CPU, we can give it the, we can specify which device to use or specify a device type. Right? And so to show you what those options are, we have a lowercase d and an uppercase d. And so we can do, you know, device, specific devices, lowercase d, and we'll give it, I could give it a 2, or device types, I could give it a 1, because that'll specify a CPU with a capital D. If we do the same thing here, and give it a D2, oops. No devices found. This should be the GPU. I did this earlier, so I'm going to cheat and go back since we're having a demo fail. I can't even find it. All right, well, we'll move on. All right. So to build out an effective Hashcat command, we have to give it a mode. Zero, give it the hash file, which has the, yeah.
Hey, John, I got a quick question for you. Where did you get those? This is from Darren. Where did you get those John the Ripper Python scripts from?
So those are included with Jon. So if you download and compile Jon yourself, or if you look in the default directories. Now, they're not necessarily in Kali. So for example, there's a lot more of them available if you download the package yourself. But if you come in here and locate star to Jon, you can see there's not a whole bunch of them in here, right? And so I was looking to see if the office to Jon was in here the other day. It's not, right? However, if I come over here, this is Slingshot. This is what we use when we teach 504 and 560. And so in the opt Jon the Ripper run directory, you can do ls-l, I'll pipe to the less. And this is the list of all the different things he has. So it's L password to Jon, or no, I'm sorry, that's a 1 password to Jon. There is a LastPass option here too. I thought that's what that was. But AIX to Jon, itself, etc. So Bitcoin to Jon, Ethereum, right? And so this is constantly updated and lots of stuff out there. Key rings, hybrid options, NetScreen, right? So different firewalls, PDFs, PFX, and there's Office to Jon, which I talked about before. Make that a little bit bigger.
Thanks, Jon. Looks like that answered it.
Okay. And then underneath, so we give Hashcat the type of attack that we want to do. We give it a hash file, and then we can specify the word list that we're going to run, right? And so you can see all the different word lists that I have out here. A bunch of different options that are very effective. And so we're just going to do Rocky real quick. And so this is going to go through, it's going to run against the top 10,000 passwords. And by top 10,000, the most frequent passwords in have I been pwned. Right? And oh, I know what I did wrong there. Should be an A. A sets the mode, and then M specifies the hash type. There we go. All right, so it ran through there. And then with the output here, you can see with Jon the Ripper, or excuse me, Jon the Ripper, Hashcat and the Rocky password list of the 10,000 most common passwords in Have I Been Pwned in, about what, 15, 20 seconds there, it cracked 9,636 of those 10,000 passwords. And that's without going through and doing, some of the optimization and that kind of stuff. So we can do the same thing at this point and then tell it to do rules. Oops. I'm running into a these are the various rules that Hashcat has built into it. So a bunch of different rules, applying all these different rules to your different password lists are pretty effective. But it's one of those things you definitely want to be familiar with what these rule sets are and how they work, because they're going to behave differently as well. So go through, run that. You see it's applying those rule sets of the best 64, still cracking some newer ones. Notice how much slower it's going in this case. So as it goes through and does those rule sets, it takes a lot more processing power for it to get that stuff going. So we cracked around another 100 passwords roughly by running the rule sets. Okay. And then also notice the utilization. So the utilization, it says 0. I mean, obviously it was going through and it was utilizing the processor, but picking the right rule sets and giving it the right password list helped quite a bit in terms of applying rules and getting the most out of that processor. So playing around with your processor and being able to know how to combine those things together so you get the most out of your processing power is important. All right. All right. Additional places where you can go to get more information, find more password lists or ways to kind of challenge yourself. One, you can go download the Have I Been Pwned dumps. So you can download everything that Have I Been Pwned has in either SHA-1 or NTLM format. It's actually NT format. It's not LM. I'm sorry to fix that. And then beyond that, you can go check out all the older Crack Me If You Can contests. A lot of those you can still download the hashes and go through. And one of the things that's cool about going through and doing those challenges is part of the challenge is you don't always know what hash you've got. And so it's going through and figuring out how to identify the different hash types and what those password cracking options look like, and optimizing that stuff and working through it. Beyond that, there's a lot that you can do with the cloud and that kind of stuff. So for instance, I don't always spin it up, but I've got one that I use as a demo in class sometimes. I have a Amazon EC2 instance with I think 16 different GPUs in it. They're not the most efficient GPUs for password cracking. They're the NVIDIA, I believe the Tesla line, so they're not the best for password cracking, but I don't have a machine with 16 GPUs sitting around that I can spin up anytime I want here at the house, but I do have that capability with Amazon. It's just a little expensive to operate. I think last time I ran it, it was about an hour. It cost me about 20 or 25 bucks, something like that, to have that thing up and going. It's definitely interesting, fun to do. All that come back to my original story. As I dug in deeper and began looking into all the different options with password cracking, like generating better password lists and optimizing my list, making sure I matched the rule sets to the password list that I was using, and figuring out how using like the -- fork and that kind of stuff, I realized how much more there was for me to do in terms of optimizing that password list. And I went back, and as I got into like focusing on like my geographic area and creating my own custom password list and running cool and all that kind of stuff, I realized that I live in Central Ohio. And if you know much about Central Ohio or the Columbus, Ohio area, there's, one sports team that really kind of dominates the airwaves, and it's Ohio State football. And there's probably people are going to like drop now because I mentioned Ohio State, but go Bucks. But I realized like I don't even know if that's in my password list. And so I went to my password list directory and I just did a grep -I against all the files looking for Buckeye and Ohio State and all that. Absolutely nothing. And I was so surprised because I really thought that if somewhere in those lists there would be Buckeyes or something, because one of those lists would have had an Ohio State fan in it somewhere, but it wasn't the case. And so when I created that custom list and put in, it's probably maybe 50 to 100 passwords of things that are relevant in Columbus, Ohio, which is where I was working at the time, and I kicked off Jon, hit enter, and it cracked like almost instantaneously. I mean, it was, I don't even know if it went a full 3 seconds before it popped up, and the password for that spreadsheet was Buckeyes and the year that I was doing the cracking. And it was one of those things, it was like, I just didn't check. The real basic thing, but the importance of customizing those lists to the situation and where you're cracking, absolutely essential to hitting those mission critical things. Any other questions at this point?
John, I got a question for you. What process would you follow to crack a dump from a SAM file or SAM file?
Well, so you've got the SAM file. That's your password hashes. At that point, it's a matter of running the password cracker against it. So the first thing you should probably do is create those custom lists. And you can try it with another tool, like one of the lists you can just go download, things like RockU. RockU it's old. I think the original dump from RockU is from 2009, but it's still really effective. And then from there, while you go create the custom list, I would go ahead and kick that off, let RockU run or the other and apply the rules to it. Go create your custom list and then run the password cracker against the hashes using the custom list and the rule sets.
Hey, John, I have a end user question, and this might be for the people who are on the call that are dealing with end users. I, the person who's talking right now, the moderator, have always feared going to the Have I Been Pwned website because I thought it would pwn me. And I'm not sure if other people have that hesitation too. Could you explain what that website is and how it works and if it's safe?
Absolutely. I'll pull it up here. So if you go out to Have I Been Pwned, you can sign up for alerts at Have I Been Pwned. You put in your email address, and if you actually administer the domain, you can set up for alerts for your domain as well. And so then you put in your information here, and then it'll tell you whether or not your email address has been identified in various breaches. And so you can go through, and so let's say bsmith@gmail.com. Yep. Oh no, pwned. And it gives the details of when that individual was pwned, right? The different times that email address has shown up in various dumps. I don't know who B. Smith is, but hopefully they've changed their password.
Awesome, thanks, John.
Yeah, no problem. There's also an API.
Go ahead.
That you can use. So if you want to use the API, you can set this stuff up either for your pen tests to see if people are compromised. Real simple stuff. So you just do things like this. So it sends out you can use like curl or request library for Python. Go query the service for identified usernames, email addresses, etc. Pull that back. And then if you want to download the password dumps, click on passwords and come down here. It's got it in SHA-1 and also NTLM version right here.
Thanks, John. If anyone has any additional questions for John, feel free to ask them now. John, I do have a question for you. How much do you get into password cracking in the classes that you teach? Is it what you just covered here, or does it go more in depth? Is there labs?
Yeah, we talk about password cracking in both 504 and 560. We have labs for each one of them. There's John the Ripper lab in 560 where you crack passwords with John the Ripper one way, and then you'll actually recompile John with a different instruction set for the processor and recrack it and compare the difference in speed between the regular compilation and the one with the advanced instruction sets, which is, it's another way to optimize that password cracking and get more out of your hardware. You just have to make sure that you're using the right version for each algorithm that you're using. And then 504, we do a lab with Jon the Ripper, and there's a new lab coming up that is going to have Hashcat in it as well. So we'll do John the Ripper on our Linux VM, and then do a password cracking lab with Hashcat on the Windows VM. But we don't go deep into kind of the difference between GPU and CPU, other than GPU's faster. There's a little bit of information there. And then beyond that, we talk about some of the different tools I mentioned here, but didn't go into as much detail about customizing for geographic locations, and looking at ways that you can get the most out of John with a given compilation, like a -- fork and some of those options.
And then my last question is, what happens when you can't crack the password?
It depends on what you're trying to crack. If it's a password like a SHA-1 or MD5 or something from a web application like that, you keep working at it. You go back to the drawing board, you try to customize your list to an individual person at that point, if you can identify the person, versus to geographic locations or companies. You want to get as close and personal with that password list as possible. So family members, pet names, that kind of thing. Another thing I like to make note of, if I can find it, as I go into a building doing a pen test, is look at custom license plates. I don't know why, but more than once I've identified custom license plates in the parking lot that end up showing up on password lists. Well, in password dumps when I'm doing pen test. So get as customized as you can, and that's if it's something that if it's not a Windows hash. If it's Windows hash, you can just execute past the hash. You would be able to just paste that into, well, there's different tools that will help you do that, like Pass Hash Toolkit, where you can just paste the element NT hash into Metasploit and execute past hash that way with some of the modules.
All right, if there are no more questions, John, if you have any final words, and then we'll turn it over to Carol to end today's webcast.
Yeah, go give it a shot. There's a lot to play with out there in the password cracking world. So if you find any good tips, let me know.
All right, Carol, it's all you.
All right. Well, thank you so much, John, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.